Thank you. Thank you for the introduction because it saves me some time. um, yeah. So thank you for being here, even if it's because it's the only English room. But I have one question. Are you familiar with Kubernetes? Yeah, raise your hand. Okay. Did you ever try to explain Kubernetes to your child, to your grandma, or someone non-technical? Not so many people there, I see. And the people who there, did you succeed? Okay, no hands raised. No, it's complicated, and we actually live in our own constructed world of digital resources. And I realized I felt like a disconnect in that sense. No, I cannot, if my daughter asks me, what are you doing? Yeah, I'm in trouble. I don't know how to explain to her. Uh, and I realized if I look at the papers, I love my job, but I look at the papers and I see what's going on. I see wars, I see the climate crisis, people all over the world less um, advantaged than us, having suffering the effects. I see waste, and I think, yeah, that's still me. Yeah, okay, it's not me, but you get my point. I'm having fun with my cloud and so on. But what can I do to make a positive impact? Can I do something about it? I come from the developing world and I live in Europe now, but I see the waste that we generate every day with food, with the plastic generation, all the garbage that we create. And actually, if you think about it, we are also creating that waste in our jobs. Did you ever find servers laying around, like applications running that shouldn't be there anymore, that are not necessary, yeah, okay. Deployment over provisioned because you wanted to be ready and then you forgot about it? Yes, it happens all the time. So I thought, well, we can do something about this. This is from a study from Cast AI, and they show that in big clusters, the basically they are so over provisioned that only 10% of the CPU on average is being utilized and 23% of memory. So we can do something about this. And I think the first step to make a change is to observe and measure and understand what is going on. So we can observe what we have, we can improve, optimize, and continue with the cycle. And what I want to talk about is that there's a lot of tools, you don't need to read the list. There's a lot of open source tools that you can use for this. I'm not going to introduce myself because happily someone has done a very good job with that. I do have to mention maybe you think developing world, but are you Italian with that name? No, I'm not. Uh, I could have been because my great grandparents lived in the Abruzzo area and then they moved to South America, to Argentina. But I'm not. And coming to Italy is a little bit like coming back home because we have so much in common, but I'm not Italian. But why am I here today? I would like, so I've been doing some work like in 2020, the beginning of Corona, I worked on a nonprofit which was dedicated to sustainability in digital infrastructure. I learned a lot that was the basis of a lot of the things I will show today. But And the idea is to show you that you, in your work, you can also apply these principles without too much effort, or at least incorporate them in your design decisions. So we will go with some practices and toolkit and yeah, tools that you can easily use. So your cluster or clusters, many clusters probably, generates greenhouse emissions. But, and also this image which I generated was generating a lot of emissions. I stopped generating images after this, but this was so good that I wanted to keep it. But there's a way to show, to have an idea what these emissions are. So how does the cluster generate emissions? First, if you have software, hardware running, you need electricity, right? So you are consuming energy. This energy needs to be generated. The generation of this energy, as a result, gives, apart from the energy, carbon emissions. That's what we call carbon intensity, because you can have energy with low intensity, like renewables, like wind and solar, or you can have energy which is very high carbon intense, like coal. And then you have the emissions generated by the hardware itself. And what does that mean? The hardware needs to be produced. So you need minerals to be mined. You need to manufacture. The manufacture process also generates emissions. And then you need, eventually, you have to discard the device because it has a certain lifetime. And that also generates emissions. Whether you recycle or you end up in a landfill, that's also generating emissions. So that's how, or some of the ways that a cluster is generating emissions. I'm not even touching upon other things like the data center needs water to cool the rack, and the construction of the data center also generated emissions. So, but this is a way which is called software carbon intensity score, is a way to have an idea of how some software running somewhere has is generating emissions. And it's called, it's an ISO standard, and it's very, well, relatively easy to calculate. So that's why a lot of people in this area are using it. And I will show one way in which you can also use it by installing a certain tool. So I'm going to talk about 6 practices. The first one, of course, measure and understand. So KEIT. KEIT is the first tool. I'm a contributor to this tool. It's called Kubernetes Emissions Insights Tool. And basically, if you look at the first 3 columns, those are the three pillars of the formula that I was talking about. So this is a Grafana dashboard. You can see for a certain period of time what was the energy consumption during that period, what was the carbon intensity in the area where you were running, and the embodied emissions of the hardware that you're using. And then you have a result. So what's that number? Well, 25,000 grams carbon. What does that mean? I don't know. So we try to compare it to real world things, like in this case, this is 200 kilometers flying an airplane. So we have I didn't mention, well, but the formula is energy multiplied by carbon intensity plus the embodied emissions. Simple enough. But for each of these pillars of the formula, we have, or in KEIT, we are using certain other open source tools. The first one is Kepler. Did anyone hear about Kepler ever? Just some hands went up. So basically, I think about it as I compare it to my tool to look at where my disk space is being consumed in my laptop. So this screenshot is from, it's not from Kepler, it's from my tool, but you can see like what are the big consumers of energy, what are the namespaces or pods that are consuming most. And you can use it on bare metal with a real hardware power meter, or you can run on public cloud, and then in that case it will use machine learning models to estimate the energy consumption. The second tool, so this we go to the second column now, is electricity maps. So this is you can go to this website, electricity maps. You can see for every region or country in the world. I don't know if it covers the whole world, but you can see the carbon intensity of that area. So, for example, I chose here the northern part of Italy where Bologna is, and I saw that there's nicely, because you can see the energy mix, you can see that there's hydropower and that there's solar power, which is very wise because there is a lot of sun I experienced in my first visit to Bologna. So, so we have the values for the energy, we have the value for the carbon intensity. We need to, because I didn't mention that the data in KEIT is collected in Prometheus, then we use another open source tool which is called Grid Intensity Go, which has basically read data from the APIs of Electricity Map and other providers, and provides a Prometheus exporter to use it. So this was, I saw there, Green Web Foundation is the responsible for this tool, and that's what we use in KEIT. So we have energy consumption, carbon intensity, and finally the embodied emissions, which in my experience is the most difficult data to get. There's an API which we use, it's called Boavista. Maybe this is from a French organization, non-profit, I think, and they basically, you can provide, like I have this instance type, what are the embodied emissions, or you can say, this is the specification of my hardware, what are the embodied emissions. So then we have the three elements, and this is basically like in the middle, the pink, red, three rectangles. Those are the three elements of the formula, and they go to Prometheus, and eventually we show them in Grafana. That's simply KEIT. So, practice number 2, run where it's cleaner. So it's kind of obvious from what I said before, no? But different countries, different regions have different carbon intensity. So if you can choose, then you can choose to go for low intensity. So I just pointed to three countries where there are AWS regions, but you can look at this information in electricity maps or any other sources, and you see that Ireland, which is probably the most popular in Europe and the first region, has pretty high carbon intensity, while Germany is lower and Sweden is by far the lowest. And if you want to run something and you can do it in Sweden, that's probably best for the environment. So, in summary, use these tools to choose your region if you have the opportunity, but you can also do what is called time shifting or temporal shifting, like run your workloads when, if they are not time sensitive, run them when the carbon intensity is low. So in Bologna, during the day when there's sun, if you have data center in Bologna or in the north of Italy. Or you also have tools which help you move your workloads in between regions, if that's possible, because sometimes you have data that you cannot, or it would be too costly to move, but that's the second one. Practice number 3, right size everything. I had another image here before this before coming here, and then my colleague told me that it was a rapist, the guy that I had the image. I had to change it, but yeah. So right size your resources. So if you have to configure your deployments, a best practice is to set your requests and limits. You should always do it for different reasons, like because you don't want to be evicted, because you want to have enough resources, etc. But you also should do it to use only what you need. And there are tools like this Goldilocks, for example, is an open source little tool which lets you. It uses the vertical pod autoscaler recommender, so it will look. You run it for a while, and then it will look what are how is your deployment using CPU and memory, and then it's recommend like this, for example. So this is like I was running it with KEIT to see what it gave, and I see that we were running too high. The CPU requests were too high. So, well, you can do this. It's a bit of work, but eventually you want your resources to run smoothly. Practice number 4, use only what you need. This is kind of an obvious one. I mean, you don't want to not have enough resources like in the first picture, but you want to also not have too much. So auto-scaling is something that is there since it was one of the best first things of the cloud. Yeah, use it. There's a cluster autoscaler, and there are tools in the different cloud providers like Carpenter, but also in Azure and GCP, so that you also only use what you need. Practice number 5, turn off what you don't use. There are tools for this as well. Of course, there's a tool for that. Cube Green, for example, you can say for this namespace, please switch off from this time to this time. So if you have development environments and your developers don't work in the night, or if you all have the same time zone or sort of overlapping, then you can save a lot. And practice number 6, become yourself the movement. So you can, in your job, you can apply this concept like it's part of the basic pillars of good architecture, right? The security is one, resilience, reliability, yeah, but sustainability as well. So apply some of these practices, talk about it with your team members, with your boss. Maybe you don't have support in the company where you are, but you can use cost as an excuse, because many of these practices reduce cost. So, and if you want to go further, you have some time, you can join open source projects. You can join the green reviews people. You can contribute to KEIT, or you can, all of these projects, just they are hungry for people to do work. One practical example, I don't know how far, it's like 5 minutes. thing. So I thought, okay, this is very nice, but let's like try to get some numbers by running an example. Um, so I made a setup on EKS on Amazon with 3 nodes, small nodes in Ireland and in Sweden, and then installed an application that I found. It's the Open Telemetry Community Demo application. Just because, not because I was using Open Telemetry for this, but because it's close to a real world application for selling something, and microservices with database and stuff, and it's resource intensive. So yeah, first I tried to install it locally, and it was too heavy to all the with all the images and stuff. Okay, this is a good example. So then I started. I had KEIT installed in the 2 clusters, and I looked what are the emissions. What are the emissions? Just like this. I look. I run it. I don't know, for an hour or 24 hours. Then I look. The first 3 rows show you the first 3 pillars of the formula. Then you have a result. And then I said, okay, what is the result for a whole year? Because you want to see, usually you run things in a longer term, you want to see what's the effect. So I had 1.8 tons of CO2 in a year. And what's that? Well, that's the equivalent of flying from Rome to Australia. So, okay, it's quite a lot, but yeah. So what if we would run in Sweden? And then the carbon intensity became like 20 times less, and the end result of the emissions, so the one before the last, was 18 times less emissions than in Ireland. So that was quite a big difference. So now we can go from Bologna to Vienna only. So it seems that it's a very big win. So then I continue with Sweden, because Sweden is clearly superior in this. So I install the application. I get the, an increase in the energy consumption. I actually had to add 4 more nodes, amazingly, and I had 3 times the emissions. So now it would be going from Bologna to Helsinki, further away. So, but I thought, okay, if I look at the dashboard, I see the energy consumption. The energy goes like crazy, shot up like crazy when I installed it. What's going on? Can I reduce, at least can I switch it off while I'm not working on it? So I switch it off during office hours with KubeGreen. And then we see immediately the CPU usage going down when it switches off, and every night it's quiet, very nice. Well, but yeah, this is how you would like simply define the sleep time. So you define what is the namespace you want to deploy down, to scale down, what time you want to sleep, what time you want to wake up, for which days. Okay, so if I look at the KubeGreen, has a sort of CO2 calculator. It has an estimation on how much you can save, and it was telling me that I was saving 43% of CO2. Okay, nice. So doing this, like, basically, if you have a lot of development, like some companies, they do run a lot of development environments because they want to test branches and so on. Well, you can, and they don't necessarily work I have a particular client, yeah, they don't work outside of office hours at all. So yeah, you can save a lot in this, and money as well. But I also thought, like, this is a lot. Like, there were nodes which were at 100 CPU, 100% CPU. So I was looking like, so actually what is consuming all that CPU and energy? Then I found that this application has a load generator. Okay, so, and that was, so this is a visualization from Kepler, which shows the energy consumption sorted by namespace, by increasing or decreasing order. So then I found this load generator that, oh, I'm going to switch that off. But then I also realized that if I look here, there's hotel demo is one of the namespace, but also default. So I realized that I had installed it twice. So I had the application running twice. So it was also one reason why it was so big. So sometimes you realize, like, doing these things, like, there's actually so many wins. Okay, you might say, like, you're a bit stupid that you installed it twice, or I was not very familiar with the application. But there's a lot of wins that you can have. At this point, I said, okay, I will uninstall the other one. And then one of my nodes which had the Prometheus data broke down, and it was Saturday evening, and I thought, okay, I have enough material. I will just stop here. So I didn't continue with any more applying anything anymore. But basically, this was what I wanted to share. It's uh, basically simple ways, or at least things that you have at your hand: measure, choose location, right size, auto scale, turn off what you don't use. Like, also look, try to sweep what you scaled out and you forgot, and make it a well-designed pillar. And you might be thinking, like, can I really make a difference? Like, what? I mean, I'm just an engineer doing my work. Why would I? But actually, I do think you can, we can. Like, I have a certain influence on my clients. Maybe it's not that much here. I'm trying to influence you as well. But imagine, like, a lot of people doing this, applying this, then you will be like a lot of multiplied efforts or added up efforts to reduce waste, means that we will be saving tons of CO2. Also, if you reduce consumption, you think, oh, but this is nothing. But over the years, because you always run things for a longer term, you don't realize that it's over a longer term, it's a lot. And bear in mind, you are the experts. So you can tell your boss, yeah, we have to set up auto scaling, we have to measure, we have to improve this. So yeah, I think you can. So I think I'm out of time, but just on time.